Okay, last lesson here on Unit 17. We're looking at classification of polygons, first off, and then we're going to look at how you can calculate interior and exterior angles of different polygons. Okay, so first off, this is what it'll tell you in the guide. A polygon is a closed figure formed by joining 3 or more line segments at their endpoints. So basically, you have a bunch of straight lines that connect together at their ends. They form a complete closed figure. If all sides are the same length, the polygon is equilateral. Now you've run into that with triangles. If a triangle is equilateral, all 3 sides are the same length. If all the angles are the same size, the polygon is equiangular. So it just means all the angles are equal. If all of the sides are the same length and all the angles are the same size, then it's what's called a regular polygon. Okay. So this thing that we've got right here is not a regular, it's a pentagon because it has 5 sides. It's not a regular pentagon because all of the angles aren't the same size. Okay, so this thing right here is equilateral, okay, because all the sides are the same length, but all the angles aren't the same. This one over here, which has 7 sides, is a regular, what do they call 7-sided? Heptagon. Because all of these are the same size, all the sides are the same length, and all of the angles are the same size. Now here's what you guys need to do on that assignment, okay? The point where the sides meet is called a vertex. So this thing right here is a vertex. A diagonal is a line segment that joins 2 vertices that are not next to each other. So if I start from this vertex that I've indicated right here, I can draw a diagonal down to here, and I can draw a diagonal over to there. Okay? And I don't want my diagonals to cross. So I always start at one vertex, and I go to the other ones to draw my diagonals. So what I have here is 5 sides on my shape, and I was able to draw 2 diagonals. And after I've drawn my 2 diagonals, what I see is I've divided my shape up into triangles. 1, 2, 3. 3 triangles. Okay. Over here, I've got 7 sides. Okay. How many diagonals can I draw? Well, if I start from one vertex, I can draw to here, to here, to here, and then down to, whoops, that one I didn't draw very nicely. So let's try this again. To here, 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 and then down to here. So I can draw 1, 2, 3, 4 diagonals. And I've split it up into triangles. How many triangles do I have? 1, 2, 3, 4, 5. 5 triangles. Okay. So how many diagonals can I draw from one vertex? Well, if I had 5 sides, I could do 2 diagonals. Okay? And when I had 7 sides, I could do 4 diagonals. So the number of diagonals is always the number of sides minus 3. Now, how many triangles could I make? Okay? So the number of triangles, let's see, I had 5 sides, and I was able to make 3 triangles. 7 sides, I was able to make 5 triangles. It's the number of sides minus 2. Okay? This is how you figure out the sum of the interior angles in any kind of polygon that you have. Okay? So, let's take a look. The sum of the interior angles of a triangle is 180. You guys have used that over and over again. If we want to find the sum of the interior angles of any polygon, we imagine dividing it into triangles by drawing those diagonals. So I've got 6 sides here. I start at one vertex, and I draw 1, 2, 3 diagonals, which gives me 1, 2, 3, 4 triangles. Each triangle has 180 degrees, so in my entire shape, I've got 4 times 180 degrees. Multiply that out, I've got 720 degrees. Okay? So that would be the sum of the interior angles of this hexagon here. Okay? All right? And you guys don't need to worry about the equation. All you need to be able to do is, if you're given a shape, split it up into the triangles. Okay? Take that number of triangles, each one gives you 180, multiply it out, that gives you the sum of the interior angles. Okay? So, for example, find the sum of the interior angles of a nonagon. How many sides do we have? Corey? 9. All right. So, we want to be able to draw a shape with 9 sides. Let's see if we can do this. 1, 2, 3, 4, 5, 6, 7, and then 8, 9. Okay. So next up, we want to draw our vertices. Okay. Our diagonals, sorry. Okay. How many triangles have I drawn here? 7 triangles. Each triangle has how many degrees? 180. So my interior angles, 7 times 180 degrees, gives me 1260. Okay? Okay? And that's what you want to be able to do. Okay? So we will stop it right there.